Thank you. While we're trying to solve the problem here, with the remote control, you did something. Well, we need standards to define that. So that's what I'm going to be talking to you about. So all these ambiguities don't work in favor because you need to compare apples with apples, oranges with oranges, or whatever other favorite fruit you may have. But that's the key thing, and that's why we need standards. And you're at the right place. ASHRAE is one of the few international societies that actually work, create, develop practical standards for us. And doing research and to fit this and doing a lot of other great things, but that's why I'm going to be talking to you about two standards out of over 100 that are available. One that is brand new in the making, and one that was just released. And I had a great introduction. Wow, I'm going to relax now because you've learned all the details. You've seen all the numbers, and I'm going to be giving you a few more. But if you recall, why are we talking about buildings? Because it's a big part of the problem we're facing. Why? Because they're using energy. Yeah, so what? What that had to do with climate crisis? They emit, they have environmental impacts. So whenever we're using energy, we, especially with fossil fuels and everything, we have also the environmental impacts. You see the significance. So that's part of the problem. And we have been pointing at the building sector and blaming the building sector. And actually, we're blaming ourselves because the building itself doesn't do anything. We are the ones that want to use the energy in order to achieve the comfort conditions and everything else. And where are things going? Well, in Europe, you've seen these numbers again because you, as engineers, need to comply with all this and help achieve them, have been setting very specific targets in terms of minimizing emissions, improving energy efficiency, and using more renewables. Now for 2030, tomorrow, that's tomorrow, you see where we need to go with this reduction of emissions, over half. That's not easy. That's really, really demanding a lot. Plus, make another observation. I cannot get my numbers right. I keep erasing them and making them more demanding straight. Well, yes, because it's a dynamic situation evolving here. So as we progress, and we're not progressing as fast, more and more we're going to be requested in a short amount of time to do more. And that's really becoming more and more challenging. Because where do we want to go? Well, this is the end of the path, and hopefully we will achieve that. It is the law, meaning it has been in the European legislation and then also in national legislation adaptation, that we want to be a decarbonized continent with all contributing sectors contributing in achieving this goal. So we need to work together to achieve this. So the building sector, it's going to be pushing this and it's going to be contributing this. Challenges, but also opportunities for all of us here. And as engineers, we're going to be walking down the path. You also saw this similar graphic and explained that up to now, we have been focusing to operational energy. How much energy are we using in our buildings? We have been doing well because we have been bringing down consumption, which is good. And then what's rising up in terms of expectations, we even have a whole session here, everybody's talking about embodied energy. Till yesterday now, we're using a little bit different terminology, embodied carbon. They're related. So this part, God, it looks more complex. Why is it so much bigger? Well, because it has more intermediate steps. But as it was very well explained, presented, look at this. For any product, material, for concrete, or for a brick, or for a heat pump or a boiler, you start with materials, excavation, everything, and then it's ready to be delivered at the gate of the factory. That represents the vast majority. That's where the main problem is at, in order to reduce that amount of embodied energy. Then you see, of course, it has to go to the construction site, and then, of course, it needs to be considered what's going to happen to this after the end of its life cycle. One interesting point that it relates to the question that Mr. Padelidis has is, how do you actually define or do all this? There's another problem of what do we include in these calculations. So whenever you see this kind of presentation, everything, pay special attention to the boundaries. Where do you draw the line? And as we will see, we walk through the new standard, it's telling you, it's providing you answers of how we will be doing this. So, this is the new standard that ASHRAE is working on. It's called 240P. What's the P? It is proposed. So it's not fixed yet. So, and it says, it's going to help you navigate exactly what you were asking through the life cycle of greenhouse gas emissions. It's a collaborative effort of ASHRAE and the International Code Council. What does it do? It provides you the methodology, get things organized to address the whole package, the building, construction materials, and the systems, mechanical, electrical, plumbing, everything. It will provide the minimum calculations, quantifications you will need to do. All right, so I get the picture, put that in there. What doesn't do? It doesn't provide you benchmarks. Because at the end, you need this. You know, we'll give you, that's why I have in the presentation another standard which is going to provide you this type of information. All right, so where's the building boundary that I told you? Well, how do you draw the line? Well, this is the big list. Yeah, blah, 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 everything. So it is everything with regard to the building, plus the maps, mechanical, electrical, and the plumbing. So it's all in there. We start, remember that graph that I gave you? With the top part. That's what we refer to the embodied. Before the building is even constructed, before it even exists, we're spending energy, and of course we have environmental impacts to produce the materials and the equipment that will go in there. So, as, again, we need to be doing in this calculation procedures, you specify your materials, and then you need, so what type of materials and how much, the quantities. So this walk through, and the standard walks you through both the design, because it may be new, but it's also applicable for an existing building. So it tells you what you need, where you're going to be getting the information in order to be able to document all this. Now, of course, whenever you do this type of calculations, and you see another excerpt from the standard in terms of how it's pulling together the information needs, you need the input data, you have uncertainties, especially for existing buildings. That's fuzzy. How do I know exactly? And that's, for example, now some clarification. If you have an existing building, you don't really worry. It's there. The damage has been done. It exists. Whatever it's going to come in new, that's what you're interested in. So relax in terms of how do I know? What am I going to get the plans and everything? It's done. So for existing buildings, everything that goes in for the renovation, for the retrofit that you have to keep track, you know, to provide this information. For the new design, of course, in the era of being blah, 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 it's easier to monitor all this information. But in terms of the uncertainties, it tells you how to make an estimate in order to take that into account in the calculations. In the embodied, beyond the materials, we have also the fugitive emissions. There was a discussion in the development, where do the fugitive emissions coming from your equipment? You have the change of a refrigerant, you have leaks. How do you account that? Is that in the embodied to the building, or it's because of its operation? It went back and forth a little bit, and it landed in the embodied, because it kind of like belongs to the building itself. So, it has all the different aspects of refrigerants. Maybe some are also used as fire suppression systems that you need to account. And there's a tricky part here, leakage. How do you really know how much you're leaking? Well, the information available is not the greatest, but there was a great job done to collect as much information, and probably more research will need to be done on this aspect to collect. And again, the standard provides you with references in the appendices of how you can get this type of hard-to-find information. All right, so we turn the page, embodied, the lower part. That's what we have been mostly focused about till now, the energy use. You heard about the EUIs, the energy use intensity of how much energy per unit flow, but in order to be able to go from the energy where to the emissions, what do you need? You need conversion factors. How do you make the conversion? If you have fossil fuels, it's pretty straightforward, all right? Where's the catch? Here, electricity. Because this is a dynamic, changing environment. Locally, and from here to here, because everything's changing. Our generation is changing, that's complementing the efforts. Again, the standard, these are extras from the standard, provide you with reference, unless, of course, on a national basis, on a local basis, you may have different requirements. Interesting, for the electrical, you need the reference here for your calculations. So you're doing it for this year, or you're doing it for 5 years down the road, how things will change. And there are information here for the US grid, power grid, projections up to 2050 of how things will change. All right, operational, it was up here, very important, but then you also have down here, water. So, for most buildings, well, we say, how important is you're pumping water, that's energy related, that also has environmental impact and everything. But there are certain applications where you may have high water consumption, or you may have desalination. Then, the water consumption and the energy related part of it becomes very important. So, again, you have guidance in terms of water use, expressed as energy per cubic meter to make at least an estimate, and for wastewater, because you have water coming in and then wastewater going out that completes the cycle. And in our graph, and that's why I said it's important to note the boundaries, you also have these parts for the future substitution, the replacement, and the possibly exported energy that needs to be accounted for. For example, an EV vehicle that you did all the time, and then it goes away from your building and your boundary. How do you account for that? At the end, it comes with your documentation. How do I communicate this information? Gets you organized with all the information and all the details. All right, sounds interesting. Where do I get more information? Well, it's out. The standard is out for public review, for your comments. That's where it is available from, and you can engage. ASHRAE makes the difference, because if that's what we think, let's hear you, what you think about this. Is it practical? Does it work for your needs? And especially they're interested for input from outside the US and North America. So go online, it's free, it's available, engage and keep it informed, of course, not only for this, but everything else. If you are intrigued, challenged, still much 18, that you can go and submit your comments and you will be heard. They will read your comments and we will try to address them. So don't think that this is going to be in vain. How do you do it? That's the webpage for ASHRAE. You sign up and you can access it now. So keep a note of this, because you can do it. No cost involved. And once you get the standard, you read it, you make your comments, because that's the idea. You go online and you submit your comments. All right. Didn't give you much, a bit more practical information, please. Well, I don't know how many of you know already ASHRAE 100. It has been one of the most practical standards that provides actually practical information for all building types and in terms of their energy consumption. Anybody? Oh, come on, at least one hand, please. ASHRAE 100. Come on, yeah, you raised yours. All right. There's another one. All right. Just yesterday, it was released with a big addition. Not only energy, but now I give you inside information about emissions, about real buildings and their contributions, in order to be able to assess compliance with regard not only to energy efficiency, but also with greenhouse gas emissions. Now we are getting practical, and voila, this is the inside information. Is that interesting, or is it just for North America? Well, okay, the inside, because this is actual energy use, okay? It's not simulation, not real buildings, real energy consumption. For the list goes on, it's long, but I cannot fit everything in there. Every building type, plus an added value here. Look at this. These are the climate zones, and it covers everything. So it includes the very freezing cold to the very hot. So every climate, every building type, energy, and emissions. And I think now you have really great resources. It was very well put in terms of the dynamic evolution, and I underline the fact that indeed things are changing, especially with the power grid. This is the picture of the EU, all the countries. How is the power grid changing at a national level in terms of the emissions? And you see how high we were back in the 90s, down to, and that's where we stand right now. What you may be interested to see, the good performers. There are countries, and it was very well said, that depending on your energy mix of how you generate electricity, you have very low emissions. That's where we want to be. That's where things are going. And everybody is trying to go down. Now, there are countries with problems more than others, like Poland, that still generates, and you see it stands up, that still emits a lot more per kilowatt hour generated of greenhouse gases because it uses primarily coal. So we need to use more renewables and some good performance, like in Sweden, the other half comes from nuclear. Now, for some countries have made a decision, we're not going to go nuclear. It's only with the backups, of course, based on renewables. Of course, green electricity is not just renewables. It's more complex than that. it is definitely a very important element, but you need to improve your distribution. You need to have more local generation for renewables to avoid going from kilometers and kilometers and having all the losses. You will need storage. And of course, you need the smartness, both in terms of the small scale building in the city and so forth. And a lot more. So to solve the problem, you need to combine different solutions. If any of this, in addition, intrigued you and interested to learn more, it's going to be an international conference, not really next door, but close to us in Madrid. It's going to be the third international conference that ASHRAE is putting together on this topic, decarbonization, what you need to know and more, in a couple of months in Madrid. The first one, we had the privilege to organize it in Athens. We have the general chair right here. Dimitris was the one that pioneered this effort, and it's catching up because there's so much interest on this topic. He went to DC on the other side of the Atlantic and came back to Europe this year. So please, if you're interested, follow up and maybe, if you can, attend. Thank you very much. You didn't scream to me all the time, so I'm doing great. Thank you.
I can give you another 2 minutes if you want to. Wow.
That's a luxury. Thank you so much for your participation. Do you have any questions?
We can have a couple of questions if you want to. Any questions?
God, I did that well.
You did more than well.
Perfect. All right, thank you.
Thank you.